Welcome back, class. Thanks for tuning in. This is going to be our last week. This is week 9, part 3. We're going to go over the Google form answers, and this will be our last video of the year. So congrats to all those who are actively participating each week. And let's go through the answers. Let's jump right to the iPad here. So what you're looking at here is my iPad. Again, we're in week 9, part 3. So it's a Google form for all the basic operations for mixed numbers and rational numbers. So, for mixed numbers or fractions and whole numbers. Now, that's what we're going to continue this week. So adding, subtracting, multiplying, dividing, any of these numbers. They could be decimals, they could be, fractions, but we're going to be learning how to, actively do them for this this part. So we have 10 problems. Let's get started here. So the first problem here is you're looking at is we're going to be dividing mixed numbers. To do this, you have to change these to improper. So you take the large number times the bottom and add the top. That's how you change it to an improper fraction. So on this first one, so this is what, 2 1/3 divided by 1 3/4. So that's our first problem here if you can't see that. So what we're going to do is we're going to take the big number times the bottom and add the top. So 2 times 3 is 6, add the 1 is 7. So this is 7/3, and we're dividing by 1 times the bottom, add the top. So 1 times 4 is 4, plus the 3 is 7/4. So we're dividing. Now, again, we don't divide fractions. What we actually do is we multiply by its reciprocal. So 7/3, we're going to multiply by 4/7. Now, when you do this, you have to actually cancel out and simplify. You could go straight across if you want, so you get 28/21. That's fine. But if you simplify this, I can divide these both by 7s diagonally or up and down. So dividing both by 7 diagonally, I get 1 and 1. Now when I multiply straight across, I get 4/3. That's an easier fraction. So how many times can 3 go into 4? It can go in there once without going over, and you'd have 1 left over if you subtracted that 3 out of it. So 4/3 is 1 full pan and 1 extra pan with 1/3 in it. That's how I kind of think of it. So there you go. There's your first problem out of the 10. Let's go to our second problem here. We're dividing again, so we're going to change this to multiplication, but we have to change these to improper. So 4 times the 2 is 8, plus the 1 is 9/2, and we're dividing by 3 times the 5 is 15, plus the 3 is 18/5. So we're dividing these. Now, we don't actually divide fractions, so we're going to change this to multiplication and flip that second fraction over. So we're getting 5/18. Now, if we do this, we can look up and down, nothing. If I look diagonal, I can simplify these by dividing these both by 9. So that's a 1 and a 2. Now when I multiply straight across, I get 5/4. And then I can simplify that. Now, if you wanted to early, you didn't need to simplify. You could just multiply 9 times 5 and then 2 times 18 and go ahead and simplify from there. You got down to the same fraction as what I have. But 5/4, that is the same thing as 1 full pan and 1 extra out of 4. So again, so how many times can 4 go into 5 without going over? It can go in there once with 1 left over. All right, the next one, we're dividing again. So 3 times the 3 is 9, plus the 2 is 11/3. And we're dividing by 5/9. So we're going to flip that second fraction over and multiply. So the second fraction flipped over. I can simplify diagonally, divide these both by 3. So I get 3 and a 1 diagonally. The 11 and the 1 can't, the 3 and the 5 can't. So if I multiply straight across, I get 33/5. Now that's a little bit bigger fraction than what we've been dealing with. So how many times can 5 go into 33 without going over? It can go in there 6 times. That would make it up to 30. 5 can go into 33 6 times, and I would have 3 left over if I subtracted 5 out 6 times. So there you go. Let's go to our next problem. We're subtracting now. We're taking from 3/4, we're taking 2 5/6 from it. So now when you actually subtract, we want to get common denominators. So we don't need to change these to improper. Just get the common denominators for the fractions. So the 4 and the 6, I'm going to make these both 12s. So on this first fraction, I multiplied by 3, so I take the top times 3, I get 9. On the second one, I took it times 2, so I take the top times 2, so I get a 10. So now at this point, we can definitely tell I cannot subtract these fractions the way that they're sitting. The reason why is that the 9 is smaller than the 10. I can go 9 minus 10 for the fraction. So I'm going to have to borrow. I'm going to borrow from the 3. Let me get rid of my camera here. There we go. And so I'm going to borrow from the 3, making this a 2. And since I borrowed from it, I'm going to add 12 12ths to the 9 12ths. So that makes it 21 over 12. Now the reason why you do that is because I'm adding a full fraction, a full 12 out of 12 to the 9 12ths. So I get 21 out of 12 because that's how I'm borrowing. And then I can that allows me to subtract this now. So if I subtract the 2's are gone. If I subtract the 21 minus the 10, I get 11 over 12. And that would be my final answer. So it's just a slight fraction left over. It's not a full whole number. All right, so let's go to the next one here. We're subtracting again. We're taking 3 1/2, and we're subtracting 1 5/6. Now again, we have to get common denominators when you subtract. So I'm going to make this a 6 and a 6. Now this one didn't change, so I'm going to leave that one alone. This one I had to multiply by 3, so I took the top times 3. And again, just like the last problem, I can't subtract those two fractions. So I'm going to borrow from the 3, making that a 2, and adding a 6 over 6 to the second fraction. So adding a full fraction to the next one. Again, when you add fractions, you just add the tops. So adding a 6 over 6 to 3 6, I get 9 6. So now this allows me to subtract. This is the correct way to borrow when you're subtracting or adding fractions. So if I subtract, 2 minus 1 is 1. And when I subtract the fractions, 9 minus the 5 is 4 6. That's how you subtract fractions. You subtract the tops. Now I know that can simplify to be 2/3, but you can leave it just like that. All right, let's go to our next problem. I only have a select few left over. So now we're adding and subtracting. So again, just like before, I want to make sure that these all have the same denominator. So I'm going to make these all 10s on the bottom. Make these all 10s. So on this first fraction, I multiplied by 2, so I'm going to take the top times 2, so I get a 6/10. On the next one, I'm going to multiply by 5, so I have to take the top times 5, so I get 5 up there. Now I can subtract straight across, so 3 minus the 2 is 1, the 9 tenths minus 6 tenths is 3 tenths. So that was just subtracting these two items. And then I can add the 1 and 5 tenths, so I'm just going to go in order left to right. So if I keep adding, I'm going to get 2 and 8 tenths, which I know can simplify, but that's the correct answer. Let's go to our next one. I think we have, 3 problems left or so. So just like before, I'm going to make these all the same denominator. I'm going to probably make them all 6s on the bottom. So let's make that a 6 here. This one already has a 6, so I'm going to leave that one alone. And make this one a 6. So on the first one, I had to multiply by 3, so take the top times 3. The second fraction was good. The last one I had to multiply by 2, take the top times 2, so I get 4. Okay, I should be able to add and subtract straight across. So if I add, I'm going to get 3 and 4 6. That's how I add these two together. And then I'm going to subtract the 1 and 4 6. Now, well, that's weird. It won't let me write that. There we go. Weird. It will not let me write that. That's so strange. Why won't it let me write the 6? All right, whatever. You understand there's a 6 there. So I'm going to subtract. Well, the two fractions literally subtract each other off. It's 4 6 and 4 6. So all I have to do is take 3 minus 1, which is 2, and that should be my answer. It doesn't even have a fraction on it. It just worked out nice and pretty. Again, apologies for that. It won't let me write in this. Oh, now it will. All right. Let's keep moving on here. We only have a couple problems left. All right. Subtracting again, I'm going to make the denominators all 12s, it looks like, so I can actually subtract them. So the second fraction need to change. This last one, I'll make that a 12. So if I take this one times 2, I get a 10. If I take this one times a 3, I take the top times 3, so I get 9. All right, so that's how you get common denominators when we're adding and subtracting. Let's subtract the first two. So subtracting the first two, I get 3 and 8 twelfths. All right. So now we're down to this part. So I can't take the 8 twelfths minus the 10 twelfths, so I'm going to have to borrow. So I'm going to make this a 2, add a 12 twelfths to that, so I get a 20 over 12. Let's subtract these. So I should get 0 out front, but I should get 20 minus 10, which is 10 twelfths. And there's your final answer. It says 10 twelfths with the 0 in front of it, technically. Okay, we got 2 problems left here. We're multiplying fractions, so when we multiply fractions, you have to go to improper fractions. So 2 times the bottom, add the top. So 2 times 3 is 6, plus the 2 is 8/3, and it is negative. And I'm going to multiply that by a negative. Let's see, 1 times 12 is 12, plus the 7 is 19/12. So when I multiply these, it'll turn out to be positive. I'm going to simplify and divide these both by 4, so that's 2 and 3. If I multiply straight across, what is 19 times? 19 times 2 on the top, I get 38 and ninths, and that can go in there exactly 4 times with 2 left over, because 9 can go in there 4 times, that'd be 36, so 2 would be left over, so 4 and 2 ninths. Okay, last problem here. Last problem, we have -2 and 3/5 times 1 and 1/4. So 2 times the 5 is 10, plus the 3 is 13/5. I'm going to multiply by what do we have? We have 1 times 4 is 4, plus 1 is 5/4. Just lost track where I was at. Simplifying, these can simplify to be 1s. So I'm going to get a -13/4 if I multiply straight across. All right, so what we're going to have here is 4 can go into that exactly 3 times without going over, and it'll be 1 left over. All right, so again, when you multiply fractions, you just make them improper and then try to simplify and go straight across. Again, thank you for those who are actively participating each week. I always really appreciate it. And good luck to all those who are going on to Algebra 1 or Geometry next year. I wish you the best of luck, and I hope to see you real soon.